Hi guys, Mrs. H here. Today we're going to be looking at velocity and position time graphs. So these would be the standards that we're going to be looking over in the following slides. Remember, you want to look for your gray background slides because those are the slides that you are going to be adding to your notes. Also in the notes, you will notice that I've given directions on what you need to do for those specific slides. So let's go ahead and get started. So what does a position time graph tell us? Well, if you notice, we have a data set down here. And so yes, all the data that you find in the graph can be found in a data table, but it just doesn't give us the visual representation that a graph does. And so when we're looking at a position time graph, it can actually tell us the relationships between position, speed, velocity, and time. And so really, what are we looking at? We're looking at position time graphs describing the motion of an object. So what can it show us? It can show us the position at various times in a runner's race. It can show us the direction that the runner is in, and it also can tell us the velocity that the runner is going in. So let's actually look at that data set in a position time graph. And so when we place this data into a graph, we will notice that we can get a slope, and that slope will actually give us that, excuse me, will give us the velocity. The slope on a position time graph will actually give us the velocity. And how does that work? So if I place position on the vertical axis and time on the y-axis with the data points between x and y, and that's always how the graph will be set up. You will always need to make sure that position is on the y-axis. Sometimes you'll see position replaced with the word displacement, and that is still the same because remember, displacement is a change in position. So you're still looking at the same information, but again, it will always be on the y-axis. And so when we look at that slope of the line, we will actually be calculating the velocity. And so how do we get the velocity from the slope? Where is that coming from? Why does that work? Well, remembering back that slope is actually a ratio of rise over run, and knowing that y is position and x is time, if we substitute position for rise and time for x, position divided by time is velocity. So we can say slope is equal to velocity. And so let's look at an example. So here we have an example. So I have two data points. I have the first data point, which is 8, 8. And if you notice, 8, 8. So that's data point 1. And then here is 3, 3. So 3, 3. And so if we take this equation, y2 minus y1, so y2, 8, minus, right here, y1, 3, so 8 minus 3, over x2, so x2 up here, 8, minus 3, so we get 5 divided by 5, or 5 over 5, equal to 1 meter. Where does the meter come from? Well, that's right here from the rise, meter, and then seconds, that's the run. So we can say 1 meter per second. And if we look at the slope is positive. So we can say that the slope of this line is 1 meter per second in a positive direction. So if this were a runner, we could say the runner has a velocity of 1 meter per second in the positive direction. So looking at this information, we can also say that the steeper the line, the faster the speed, or the faster the velocity is. So if we look at these two cars and we just look them driving down the road, we can clearly see that the red car has a higher velocity than the blue car. And so if we look down at the graph, we can also clearly see that the red line excuse me, the red line has a steeper slope, so therefore it has a faster speed. So applying that information, which runner has a faster constant speed, or we could say has a faster constant velocity? And how do you know this? What information on the graph is allowing you to draw that conclusion? So here is again, kind of putting this all together on a position time graph, or again, displacement over time, same thing, same information. So this first portion, we have a slope. It's a constant velocity, a constant slope because it's not changing. So we can say it has a positive velocity and it's moving in a positive direction because the slope is positive. We can also say that it's moving away from, in a positive direction, the origin. Now this one, notice the slope is negative. So because the slope is negative, that means the velocity would be negative. It is also moving towards home. So this we would say has a negative direction. Now what happens down here? This still is a negative direction, but notice what happens. It's a negative direction and a negative velocity, but this time it's negative because it's moving away from home, which is also a negative direction. And then here we have a situation where, if you notice, at 10 seconds and 15 seconds, the runner is at 4, a position of 4. So it has not changed position. So we can say that the runner would be stopped. Now, I've been using runner. This could be a car. This could be anything that's having motion. It could be a dog. It could be a cat. Any object that is having motion. I just did for today's lesson have been using the word runner. So I hope that this has been helpful. If you have any questions, make sure you're always reaching out to me. Bye, guys. Have a good day.